down 2x plus 3 all over 4 minus 4/3 equals 1/4. So you have to fraction bust on these or it does not work, okay? So you want to solve it by canceling fractions. So you look at the denominator and you have a 4, a 3, and a 4. And you're like, what is the smallest number that 4, 3, and 4 go into? Yeah, 12. So I like to write a little 12 next to each term. Okay. So I'm multiplying everybody by 12. You want to divide first. It's easier. So how many times does 4 go into 12? Okay. So I am going to multiply the 3 times this entire numerator here for the first term. All right. So it's going to distribute. That's something people forget. If you've got like a plus sign in there, be sure you distribute. So this gives me a 6x plus 9. Okay, now I go to the next one, and Simon, how many times does 3 go into 12? 4. All right, and then we just multiply here, 4 times 4. Now, don't lose the negative sign, so that would be a minus 16. Okay, and Izzy, how many times does 4 go into 12 over here? 3 times. And then I multiply the 3 times the 1, so I get a 3. Okay, once you do the first step correct, you usually can get this problem right because it's just basic algebra, right? So now I'm going to combine these. 9 minus 16 is negative 7. And then I'm going to add 7 to both sides. And then I'm going to divide by 6. And I get 10/6, but you do want to reduce that to 5/3. All right. Now on this next one, we're all going to change this sign right here because this is where everyone messes up to a minus. And I'll show you why. All right. So we're going to make it a minus. No, don't change the signs for every problem. I'm only changing this one because it's like what people mess up on. All right. Just to make sure I point out common errors. Yeah, don't change the signs on the homework. All right. So I have 4x over 3 minus 7 minus 2x over 5 equals 2. So the first thing you're going to ask yourself is what does the smallest number 3 and 5 go into? And Anders, what do you get? Okay, so I'm going to put a 15 next to each term. Okay, or you can do like a big set of parentheses with a 15 as well. So Sophia F, how many times does 3 go into 15? 5. Good. And Christine, now when I multiply, what do I get right here? Good, 20x. Excellent. All right. And Julia, how many times does 5 go into 15 right here? 3 times. And this is where people mess up. Okay, you are distributing the 3, right, to this entire numerator. What else should you be distributing? Yes. So this is really a negative 3. And that's where everybody messes up, is they tend to only put it on the first term, and everybody forgets to also distribute it to the second term. Okay, so the negative distributes, because this was a minus right here in the problem. Okay, so now I have a negative 21, and then a negative times a negative is a positive 6x. Okay, and then on the other side, even though there's no fraction, you still have to multiply the 2 times 15. So I have 30. And hopefully if you get to here, it's like smooth sailing, all right? So 20x plus 6x is 26x. And then I have minus 21 equals 30. Okay, I'm going to add 21 to both sides. That gives me 51. And I'm going to divide by 26. That gives me 51 over 26, which I don't think reduces, so we're good to go. I know. Could have been. Yeah.
So, do we need to write like the 15 times everything, or can we just write like the 20x minus 21?
You can just write this.
Great.
Yep. Just be real careful with your negatives. Yes.
So when you changed the plus or minus, were you changing the fundamentals of the problem?
Yeah.
Okay.
I just wanted to start with the negative because no, don't change that like in general.
Yeah.
No. Like, so if it was a plus sign, it's just that people don't mess up as much when there's a plus sign because you're like, oh yeah, I would get a 3 and I would distribute the 3, and they're good to go. Okay, everyone messes up when this is a minus sign that needs to distribute to the top. That's why I wanted to show you one with a minus sign. That was it. Okay, all right. Go ahead and draw these triangles. We really like similar triangles, okay? Saxon really likes similar triangles. Okay, you guys, so they already tell us that this angle is congruent to this angle. Also, the triangles, they share the top angle, okay? So that's congruent. And then we learned that if we know 2 angles, we know 3 angles. So I also know that this third angle is congruent to this third angle. So I basically have, if you want to draw them separately, this is like the little triangle, and it's proportional to the big triangle. Okay, when you draw the big triangle, this side is y, right? So I'm drawing this big one. What should I write for the actual length of this side, Sophia? Yes, this is the most important thing to remember. Add those together, you guys, for the total of that big triangle, right? Same over here. If I was trying to do this side, this would be 3 plus x. However, I'm going to show you an easier way to find x. But, all right. So if I want to find y, you have to use the whole big triangles like these. So we have to actually look at this and this. So tell me, somebody raise your hand how I can write the proportions to find y. Will?
4 over y equals 5. Yeah.
Close.
Sorry, 2 over 5.
Yep, there you go. Okay, so if you do the 4 to the y, the little one to the big one, then you can do the little one to the big one. Now, you don't have to draw the triangles separate. You just need to remember to add this right here, okay? So that's one way to do it. Now let's say I want to find x. Raise your hand if you could write how to find x. Christian, in the back. Oh, I thought you were raising your hand. Okay, Sophia. Say that again. Yes. Okay. You could do this, right? And then you would have to like distribute that to that. So you would actually do like 6 plus 2x equals 15 when you cross multiply it. All right. However, there is an easier way that I would like to show you for x. So if we look back at the original, so I'm going to actually clear this really quick. Hold on. Edit. Clear ink. Ooh, okay. These lines right here are parallel lines. Okay, I just missed, but this line right here is parallel to this line right here. And also that means that that x should be like, you know, a little bit more like right here. Okay, and this 3 is like right here. If you think of those as parallel lines, which they are, now it's a little easier to do it this way. So raise your hand if you can find x the parallel line way. Josh? What'd you say? Sure, yes, but let's set up the fractions. 2 over 3 equals 3 over x. This over this equals this over this. You can split it, but only on those pieces that are parallel. So like don't split the y side, all right? So again, when you want to find y, you're going to have to do the sum. You're going to have to do 5. You cannot use a 3 or a 2, okay? Yes?
What if you find this way so much more complicated?
This way? Oh, you can do the sum way and like draw them and distribute the way I originally did it. That works too. However you want to do it, it's fine. All right, let's try some whiteboards. A few people, you guys were like confused on this one. You need, before you start, like please make these improper. Okay, and then multiply. We didn't have one like that, but make sure you make. Okay, you guys, let's try the next one. All right, you guys, last one, similar triangle.